Bismillah ar-Rahman ar-Rahim. Students, today we will discuss this chapter number 2. And in this chapter, we have a lot of concepts. And this is very, very important for your examination point of view. So you must learn all these things carefully. So chapter number 2 is related with motion in one dimension. Chapter number 2. This is related with motion in one dimension. So before discussing this motion in one dimension, first we will see the types of the motions. Types of motion. So in types of motion, we have translational motion, and we have a rotational motion, and then we have vibrational motion. Okay. So here in this chapter, only we will discuss this translational motion, the motion in a straight line. Rotational mean it is moving like this one in a circular path in a rotation way. And vibrational mean it is moving to and fro. To and fro mean you have seen the motion of the pendulum. This pendulum motion is like this one. It is moving like this. This is called pendulum motion. Okay. But our target is motion in one dimension. So motion in one dimension mean either the body is moving like this one, or it is moving in this way, or it is moving upward, or it is moving downward. So we will discuss only these cases. The body is not moving like this one, or the body is not moving like this one, okay, in the curved path. So our target is one-dimensional motion, first thing. So after this, one-dimensional motion, we have some terms which we will discuss in chapter number 2. Number 1 is position. Number 2 is distance. Number 3 is displacement. Number 4 is speed. Number 5 is velocity. So velocity has many kinds we will discuss: constant velocity, variable velocity, instantaneous velocity, like this one, average velocity, average speed. And then we will discuss acceleration. And after acceleration, then you will use the equations of motions for constant acceleration. Okay. So these are the terms which we will discuss in chapter number 2, all these terms. So first I will discuss with you the 3 most important terms, the basic terms. So here we have a position. Position mean what? Position mean the location of the particle or the body, location of a particle. Particle from some reference point. Some reference point. A reference point mean from that point where you are starting and where you are ending or stopping, that is your location. I will give you example. So the next is the distance. Then is the displacement. So I just want to tell you the difference between this one. The distance mean it is the length between 2 points. This is the length of 2 points. This is called distance. And the displacement is if we are taking the length, but with some direction, either the direction is right side or the direction is left side. If we show or mention the direction, then it is called displacement. Otherwise, it is a distance. So, to explain it more, let's see one example. The example is this one. If we have this y-axis and x-axis, this point is 0, 1, 2, 3, and 4. And this is -1, -2, -3, and -4, suppose. If any object or any body is starting from 4, this is a point, it is starting from 4, this is the starting point, and it is going in this way and stop at -4. It is starting and this is stopping at -4. The question is, what is the position?
0.
What is the position of the object? Position mean what? The location. So what is the location? Location is -4.
-4.
Location is -4. Okay. Now the question is, what is the distance?
8.
8.
Distance will be 8 plus. Distance is always positive. Always positive. Okay. Now the question is, what is the displacement?
-8.
-8.
Displacement, when you write the displacement, just remember xf minus xi. Your xi is this value. Your xf is this value. So xf is -4 minus this minus and 4. The answer will be -8. So your displacement is -8. Your distance is +8. Your position is -4. So when you find the displacement, you always find xf minus xi. Or you can find the distance xf minus xi, but with positive sign, because the distance is always positive. Now understand this one.
Yes, all clear.
Okay. After this, I remember this one, that distance is always greater than or equal to. This means greater than or equal to displacement. It can be greater or it can be equal, but displacement will never be greater than distance. So this is the conclusion from this. Okay, if delta x is greater than 0, it means what? It means xf is greater than xi, because delta x mean what? Delta x mean xf minus xi. So xf is delta x greater than 0 mean positive. So the motion is always towards right side. If delta x is positive, it means the motion is right side. If the delta x is less than 0, mean negative, so xf will be less than xi, and the motion will be
Left.
towards left. If delta x is 0, then
No, there's no displacement.
let's see. Yes. If delta x is 0, it means xf is equal to xi. So if xf is equal to xi, it means the body is moving in this way and come back to this point, or it is at rest. Understand? If it covers a distance d in this direction, it is minus d because it is left side, and it covers a distance d plus side, same distance. Okay. So what will be the displacement? Delta x mean here displacement. So what will be the displacement? The displacement will be 0. Okay. If a body moves from A to B with 15 meter, then come back to A with 15 meter, same. So what is the displacement?
0
0.
0.
0.
0
What is the distance?
30
30.
30. Okay.
okay
Distance is without direction. I think you understand this one. Okay, after this. So I just focus on 3 points. One is the position, one is the distance, and one is the displacement. Only I focus on these 3 points. Now I am moving forward. The next terms I want to explain the speed and the velocity. Okay, so speed. See the speed. Speed is what you have studied in your
Distance over time.
distance over time. This is called speed. But normally we measure the average speed. Average speed. So average speed mean what? The total distance over the total time. This is mean average speed. So total distance mean what? And total time mean what? If a
Delta
body is
B.
if a body is moving from A to B and then B to C, it covers a distance D1. It covers a distance D2. Okay. It covers a distance D1 in time T1. It covers a distance from B to C in time T2. So I can write this formula. V average is equal to D1 plus T2 over T1 plus T2. Understand? One thing. The second thing, if a body is moving from A to B, having distance D, B to C, having distance D, same distance, same, but their speeds are different. Here is 70 km per hour. Here is 90 km per hour. How you can find the average speed? This is important. Let's see.
I might remember, but I think it's the initial, because I mean final speed minus the initial speed, yeah?
No, no, no,
Over,
no, 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 no.
Okay, that's
no. Okay,
I
see,
thought it was something else.
from A to B, B to C. This is D, this is D, this is 70 km per hour. Don't need convert it into meter per. Just if the answer is in kilometer per hour, then solve it like this. 90 km per hour. Okay. So our formula is V average is equal to total distance over total time, D plus D over T1 plus T2. Okay. So T1 is what? T1 is the distance divided by the speed. Understand? T2 is what? The distance divided by the speed. So putting this value, 2D over T1, D over 70, D over 90. Okay. So 2D over here D is common. 1 over 70 plus 1 over 90. This D will cancel with this D. Answer will be what? 2 over 1 over 70 plus 1 over 90. You can solve this one with the help of calculator and write your answer. And this is your average speed. Yes. Question.
I have a question, sir.
Yes.
If we instead of did this, if we just converted to find the t to then put it in the first
Yes.
method, is it okay?
Yes. I just
Even
find that
the-
because I know from A to B, the distance from B to C is the same, but their speeds are different. So it means their time is different.
Yeah.
So that's why I find the time.
Understood. Thank you.
Yes. Any other student? I think you understand. This is easy and simple. But remember the formula of this one. This formula you can see that this formula is very simple. D plus D, remember this one, D1 plus D2 over T1 plus T2. So according to situation, you can put the values and solve it. Although the formula is total distance over total time. Other thing is nothing here. Okay. After this, so remember that speed is distance over time, not a displacement over time. Distance over time. So speed has no direction. It is a scalar quantity. If any quantity has no direction, it is called scalar. So if I write 100 kilometer per hour, it is speed. If I write 100 kilometer per hour towards north, east, west, south, this is velocity. So I'm coming towards velocity. Velocity is normally defined in the books. It is written that delta x over delta t mean what? Displacement. It is not distance. Displacement over time. So displacement over time is called velocity. So you can write this equation xf minus xi over delta t, or tf minus ti. You can write xf minus xi over tf minus ti. I am putting here bar. This bar mean it is a vector quantity. It is a vector quantity because velocity is related with displacement. Velocity is related with displacement. Displacement is related with distance plus direction. Displacement mean what? Distance plus direction. If I am not mentioning the direction, then it is a distance. So distance you can use with speed, for speed, but displacement you can use for velocity. So the question is, what is the direction of the velocity? The direction of the displacement. The direction of the displacement is the direction of the velocity. So I think you understand this one. Okay, the velocity unit is what? You know this one, meter per second, and also it is meter per second in SI system. But here I just give you one example. Okay. After this, the most important concept is to describe the velocity from displacement time. If you know the displacement time, you can describe the velocity. If you know the displacement time, you can describe the velocity. How? So this is very important concept, and maybe you have studied at high school level. So I'm just explaining the graphs of this one. I'm not explaining here the other things, but first I will show you the graphs. Okay, but first I will show you the some concept of constant velocity. Constant velocity mean what? Constant velocity mean if a body moves from A to B, then B to C, it covers the same distance in equal time. It covers the same distance in equal interval of time. Then we call it the velocity is constant. If it covers equal displacement in non-equal interval of time or in equal interval of time, non-equal displacement, then we call it variable velocity. Then we call it variable velocity. Variable velocity means the velocity is changing because it is not covering equal distance in equal interval of time. If it is covering equal interval, time, then it is constant velocity. So remember this one, constant velocity and variable velocity. But I want to explain the graphical pictures of this velocity.
Sir,
So
can you explain variable and constant again? I didn't
constant,
understand.
yes, constant velocity mean that this is the distance displacement or distance d, and this is also d. So if it covers this distance in equal interval of time mean in first 10 seconds the same distance, then other 10 seconds the same distance, then other 10 seconds the same distance, then other 10 seconds the same distance, then we call its velocity is constant. Okay. If
Okay.
it covers the same distance in suppose 10 seconds, the other same distance in 5 seconds, the other same distance in 20 seconds, so you can say that its velocity is constant. No, its velocity is variable. It means
See.
it is you are accelerating and then removing your feet from the accelerator, then putting, then like this one. Okay. So the most important things are the graphical pictures. Graphical explanation. I just explain you position, distance, displacement, distance, speed, and velocity. Now we are focusing on displacement and velocity. We are making the connection through graphs between velocity and displacement. How? Let's see. This is the graph lines, x-axis and y-axis. X-axis is time axis and y-axis is displacement in meter. So if our graph is, shape of the graph is like this one, what is the meaning of this one? It means you are increasing the time and your value is constantly increasing. Constantly increasing mean what? If I draw this line here, it means it is constantly increasing. If I draw the line here, it means it is increasing constantly. Okay. Constantly increasing. So constantly increasing mean that its velocity is constant. How I know? Okay. So we know that velocity is what? delta x over delta t. Rate of change of velocity, rate of change of displacement is called velocity. And this delta x over delta t in mathematics, it is called slope in mathematics. And slope is equal to theta or tan theta. In mathematics, it is equal to tan theta. And this is normally equal to theta. So slope formula in mathematics is what? Y2 minus Y1 over X2 minus X2. X2 minus X1. This is our formula. How we can apply this formula here? No, I want to explain in the next slide. See, if I have this graph xt and this is the line and these are the points, this point is 0, 0. And this point is suppose 5 or 2. This point is x1, y1. This point is x2, y2. Okay. The slope is equal to y2 minus y1 over x2 minus x1. Y2 is 2. 2 minus y1, 0. x2, 5, 0. Answer is 2 over 5. And this is equal to slope. And slope is equal to what? Velocity. And this slope is also called tan theta. Or you can say theta. Tan theta is approximately equal to theta if the value of theta is very, very small. But I'm writing here theta or tan theta. You can do this one. But understand the slope. Slope, you understand, this is a slope. This angle is theta. If I make this slope here, this angle is theta. If I make this angle is here, the angle is theta. Okay. So from this graph, you will find the slope. If the slope value is constant for any 2 points, for these 2 points, for these 2 points, for these 2 points, then we will say that its velocity is constant because the slope is constant. Understand? Okay. Let's see again. If we have this graph and it is like this one, and we want to make the velocity time graph, because we know that slope is constant. Slope is constant here. And this value is positively constant because this value is positive, not negative. So where will be the, suppose if I find the slope here, my answer is 5. If I find the slope here, answer is 5. If I find the slope, answer is 5. 5, 5, 5, 5. At every point, it is 5, 5, 5. So what will be the velocity time graph? It will be like this, 5. Because the time is going on, the value is 5. Here 5, here 5, here 5, here 5. All points should be at the same level, at 5. So the velocity time graph for this x displacement time graph is this one. So what I want to explain, what I want to give you the concept. I want to give you the concept. If xt graph is a straight line like this one, which I have made, what will be the velocity time graph? The velocity time graph will be the slope of this one. So the slope is constant. But if this line is like this one, the slope is changing, then velocity time graph will not be like this one. It will be curved path. But here at your level, we are normally drawing the line of this one. Okay. Understand this one? One thing. Okay. After this, if my xt graph is not like this one, it is like this one. What is the slope here?
0.
0. Slope 0 mean what? Velocity 0. Slope 0 mean what? Velocity 0. So what will be the VT graph? The VT graph will be like this on the 0 axis. This is 0, 0 axis. Okay. The VT graph is this. Now you have seen two situations. One is this one. The graph is this one. And the second situation is this one. If the graph line is parallel to x-axis, its slope is 0. The graph will be like this one. If xt graph is this one, it means the velocity is increasing. Velocity is increasing, but constantly increasing. The slope is constant. So the slope constant means the velocity value is constant. How much constant? Some value. So some value I put line here. But here I put the line here. Why? Because the answer is, slope answer is 0. So that's why I put the line here. Okay, clear? After these two situations, now I want to discuss another situation. This is xt and the graph is curved like this one. So at this point, I'm making 2, 3, 4 points here. If you want to draw a tangent line, this is tangent line. It is cutting the x-axis here. If you want to draw the tangent line, it is cutting x-axis here. If you want to draw the tangent line, it is cutting x-axis. Maybe I have made not very good. I just draw again. Okay, see. If I draw the line, it's like this one. If I draw the line, it's like this one. If I draw the line, it's like this one. So the theta angle, this theta is called slope. Okay. So the theta angle is increasing or decreasing?
Increasing.
Increasing. Good. Theta is increasing. Theta increasing means slope is increasing. Slope increasing mean velocity is increasing. So this velocity is increasing, but constantly increasing. So the velocity time graph will be like this, constantly increasing. It is constant, but increasing. In the previous case, previous slide, you can see it is constant. Here, the value is constant, but not increasing. But in this case, it is constant, but increasing, constantly increasing. Okay, understand? This line and this line are same? No. It has different meanings. It means it is constant. Constant at 5 or 10 or whatever. But it is increasing constantly. Why increasing constantly, I am saying? Because if you want to find the slope, it will be constant. Yes.
So we're gonna say like it's constantly increasing means like every 1 second it increased
Yes.
by 5 meters like velocity
Yes.
or
Yes.
speed.
Yes. Yes.
And it's every second it increased in the same amount or same rate.
Yes.
Okay,
Okay. After this, now I have made 3 situations. One x is like this one. This is xt. One x is like this one, xt. And one x is like this one. Okay. Now I want to discuss the situation xt and the situation is like this one. You can see it is the invert of this one. Okay. If you see this one, this is the invert of this one. On the next slide, see, I make this graph like this one. Okay, this is X. Sorry. Where is this one? Okay, see this one. Now this is X, this is T. So the point is here. 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 I make this line extend. Okay, you draw a tangent line. This is your angle. You draw a tangent line. Your angle is here. You draw a tangent line. Your angle is here. You draw a tangent line. Your angle is here. You draw a tangent line. Your angle is here. So the angle is increasing or decreasing?
Decreasing.
Increasing then decreasing.
Decreasing.
No, decreasing.
It is decreasing because it is bending this side. Okay. So it is decreasing. So if it is decreasing, then velocity time graph will be what? Velocity time graph mean it is decreasing constantly. So if it is decreasing constantly, the velocity time graph will be like this one. Because at initial position, it is maximum. Then here, then here, then here, then here. Okay, understand?
Yes, so clear.
Understood, doctor.
So these are the brother situations which I have discussed with you from XT graph, how we can make the VT graph. Okay. So only today I have discussed with you the position, the distance, the displacement, the speed, and the velocity. Okay. And this graphical situations, but I will discuss with you the more graphical situations in the next lecture, not today. If you have any question, you can ask me. I will discuss with you again the constant velocity, the variable, and one more left is the instantaneous velocity. Instantaneous velocity mean at that particular time. At that particular time mean if the 2 points are very, very close. You will see here, if I have this point, line, these 2 points, if these 2 points are very, very close, then they become here. Okay. So you can find the instantaneous velocity for that particular time. I am giving you one example. You can understand. If I want to ask you that what is the time, you are saying the time is 10:45 or 10:40 and 10:40 and 30 seconds. It means you are telling me the instantaneous time. Instantaneous time mean you watch or you see your watch and tell me. So when you are telling me the second needle, that time moves forward. But when you see the watch, you tell me, it means this is your instantaneous time. So instantaneous velocity mean when you see the speedometer, you see the meter of your car and tell that my car speed is suppose 100 km/h. For that time, when you see, that's why it is called instantaneous. Okay, so its formula is the same one, but we will solve the problems of instantaneous velocity for that particular time. So the time value will be fixed. So we will solve the problems of velocity, average velocity, and speed, average speed, instantaneous velocity, especially instantaneous velocity. And here the values will not be some, you will see the values will not be given in the numbers form. Sometimes it is given in the equation form. x is equal to 0.5 t plus 0.2, like this one. So he's asking, what is the distance at 1 second? So what you will do? So you have a time t. So for t is equal to 1 second, you will put the value of t 1 second and solve it. And then you will find this x value 0.5 plus 0.2. So it means this 0.7 is the value for 1 second. And this is your instantaneous distance. So if you know the instantaneous distance, you can find the instantaneous velocity. Okay. So this is all about today, the lecture. And next time I will discuss more in detail about velocity and instantaneous velocity, and then acceleration. Acceleration is more tricky and tedious term as compared to velocity. So
Doctor,
yes.
will you give us some examples?
Yes, we will solve a lot of problems,
Okay.
not some example. You will
Yeah, good.
see on this platform. This is not some problem. No. Otherwise, you cannot solve the problems in the exam. I am 100% sure, because maybe 3, 4, 5 students have a very good knowledge at high school level, but mostly, which I have experienced. I don't know what's the position of your class, but normally the students, some students are very weak knowledge. Okay, so I will explain everything here, and I will solve the problems, lot of problems, not some problem.
Okay, thank you, Doctor.
Yeah, you will see. You will see. Time will tell us. Inshallah. Yes. Any question? If you have any question, you can ask me. Okay, so if you don't have any question, so see you in the next lecture next week. Okay. Thank you.
Thank you, teacher.
Yeah, thanks.
Thank you, Doctor.
Thank you.
See you next week, doctor.
Inshallah. Okay. Thank you.
Inshallah.
Assalamu alaikum.
Bye. So.